Hey guys, welcome to my YouTube channel. So this video is regarding part 2 of the chat server basically. So basically I had made a video regarding chat server in my YouTube channel which basically teaches you how you can build a chat server from scratch. But that was a very basic video where it would show you like how to implement just the basic messaging functionality. But later on, I kept working on this project and added a couple of new interesting features such as private chat and setting status and sort of like many other features which I will show it to you in the demo now. And after I had a couple of features, I posted it on Reddit to get some feedback from senior devs. And one of the feedback was really detailed and interesting, and I incorporated that feedback into the code as well. And the feedback is really good, and I feel that you can also learn a lot of things from the feedback and how I incorporated it into my code. So let me first show you the demo, and then I will show you the feedback that was given to me, and then how I implemented it. Okay, so let's look at the demo. So first let's run the chat server make run. So I made a make file also because it just becomes easier to run the code. So the make file just runs all of these files: main.go, database.go, and private message.go. So yeah, so now the server is running, and the way you would connect to this server is using this command nc localhost 8080. Now once you connect to the chat server, you have to register because that's the safest way for us to validate users, because you need to only let users who are registered to use the product. So first let's register Mike, and username password is 1234. Okay, display name is also Mike. Okay, now Mike has joined the chat. Now okay, sorry, let me write that command nc nc localhost 8080. Okay, register Peter 12345. Okay, now the name also will be Peter itself. So Peter is joined the chat. So basically the way this works is hi everyone. So this is a common chat. When Peter types hi everyone, it's visible to everyone. And then there are a couple of functionalities. So suppose if you do hash users, it will show you all the users. Okay, so you might be wondering what are all these previous things. I mean, these are all the users I had registered before while sort of testing this product. So the new users are just Peter and Mike. Okay, now current this user is basically Mike. So let me send a private message to Peter telling hello Peter. Now Peter got the private message from Mike telling hello Peter. So this is one of the functionalities. And then you can also set status. So status for Peter will be bored. So status has been set. Now if you go here and again do /users, you can see that Peter's status also comes bold. I can set it for Mike also. So he is basically happy now. Yeah. Now again, if you do use /users, you will get Peter and Mike. So this is how you can set status. And I also showed you how to send private messages. So help gives you like all the options that you have. And one other thing, I also have this reply hash reply, which basically is used to reply to the last private message you received. So for example, Peter received hello Peter from Mike. So you can just reply to Mike directly by hash reply. Hello Mike. So yeah, private from Peter, hello Mike. So I think I showed you everything. Login is just like once you are already registered, you can just log in. You don't have to register again. I showed you slash users, private, and then exit, help. Yeah, that's pretty much the functionality. And then to exit, you can just do this. So let's exit. Yeah. Now I will show you like what was the feedback sort of given to me by one of the devs. So basically, if you see here, there are a couple of feedbacks that were given to me. One was the user this was the initial product that I had. The user was being stored in the memory. So initially the user were stored in a JSON file. So they were like it is stored in the memory and returned to a file. So that's a problem at scale. Use DB, you will need distributed support eventually. So yeah, this was one of the comment that was given. So if you see here, I implemented the DB. So I used SQLite. So the db.go consists of couple of functions. Init db, which basically initializes the database. The database consists of username, password, and status. So init db will basically like initialize the db, and save users will basically insert that user into the db. If you see, we are running db.exec, it inserts the user into the db. And also while inserting the user, you need to make sure the password is encrypted. So we are making use of this bcrypt method to sort of encrypt the password and add it to the db. And then we have this verify user, which sort of fetches the user from the db and also sort of returns it if the user is present in the db, and also if the password and everything matches. And we have update user status, which basically sets the status of the user and updates it in the db as well. And again, get user status just retrieves that status from the db. And get all user function basically selects all users from the db. And close connection, it basically used to close the db connection. So this is the database implementation. That was one of the first feedbacks that was given that I incorporated. And you also have to make changes in the main.go file. So if you see here in the main, first thing we need to do is initialize the db and defer close db. So once this main function is done, you will call the defer to close the db. And then again, like at couple of places, like let's say at register we again make use of db.query row, um, to basically get the count of number of users with that username present. And if more than 0 count is there, that means if a user is already present, you will be like username already exists, choose a different one. So basically, in wherever I had a JSON file, I swapped it with a DB to make it more distributed and scalable. And yeah, so and I also have at status, like even in this function, you basically have to make a call to update user status in the DB. So at a couple of places here, I have made the DB call, but all the functions regarding the DB has been implemented in this database.go file, which has all the database function, and I'm using SQLite. So that was one of the feedbacks. And the other feedback that was given was I can send an username and password of any length, and also think about what it means if I flood the server with register commands. I could just knock the server offline. Yeah, this is again a very good feedback. So basically, like I was not checking the length of the username and password that has been sent by the user. So like this, it will make the code vulnerable, wherein they can like flood it with a very large username and password. And they also made a point that they can register any number of users, so that will flood my server. So let us see how I handled it. So basically, to handle this, the first part to handle the length of username and password was straightforward. For that, like I basically let me let me check where I handled it. Yeah, here. So for that, I basically had just sort of checked the length of username and password and restricted it to just 10. And if it is greater than length, I just give out a message that it should be like 10 characters or less. And then to handle rate limiting, we need to implement a server side rate limiter. This is a very important concept. So let me show you how I did it. So we basically implemented a rate limiter function. So basically what it does, it fetches the IP of the user, and then we also, okay, even before that we need to create these maps. So one of the maps IP to number of times that they have made a register request, and also the other map is a map of IP to last attempt time. So basically the last time that they made the register call. And then this mutex is to make these maps thread safe. So what basically we're doing is first apply a lock because it's a global variable, and then defer unlock. So after you execute entire thing, you execute unlock. So get the current time and get the last attempt made by that IP. Basically the time of the last attempt made by that IP. And then if that IP address exists, and if the last attempt now dot sub will check like when was the last attempt made, was it has it been more than a minute after the last attempt has been made. Basically in this rate limiter we are limiting it such that in a minute you can make only 3 register calls. So using this function we are checking time dot minute will return like 60 seconds. So basically like what was the last um, time we made the register call. If it is more than 1 minute, then it's fine, so we will reset the counter for that IP address. If not, if the number of calls made is greater than 3 in that 1 minute, then we need to rate limit it, so we return true. Otherwise we just increment the number of calls made, and then we update the last time the register call was made in this other map register times, and then we return false. It shouldn't be rate limited. It should be only rate limited only if we make more than 3 attempts in 1 minute. And I hope you understood that. Here we are just checking if the IP address exists, and time dot minute will give you like 60 seconds, and we are taking the last attempt time made, and we are seeing like was it after 1 minute, was it after 60 seconds, after like we are basically taking the current time and the last attempt made, and we are checking whether 60 minutes have 60 seconds has passed or not. If the 60 seconds has passed, then we can reset the counter because this is like a new window, because we are limiting it to 3 requests per minute. So if that window of 1 minute has passed, you need to reset the map. Otherwise, just increment the map and then set the latest time. And if you cross the tree limit, 3 request mark, return true. I hope you understood the rate limiting. This is the most important part of this tutorial. And then, okay, let's look at the other feedbacks. Yeah. Okay, then same for message of any type. Actually, you need sanitation. Okay, basically the length of message and everything. Yeah, that I still have to add. I mainly handled the length of username and password. Same thing also has to be done for each of the message. And that telling single mutex for entire application is easy, but is it correct? Mm, but here I actually don't have single mutex. I basically have like a mutex for different use cases. So basically, this mutex is for like um, using these maps like client and client map and connection name to connection map. And then for register, I have a separate mutex. Probably they mean to tell that I need to have separate mutex for each of these maps like client, name to connection, and display. And yeah, even that change can also be made. Currently, like I don't have mutex for each thing. Uh, let's also see like what other feedback is there. What is the point of register and login process? It will make sense if you add message storage. Yeah, I added message storage now. And then friend list, ban, block list. These functionalities are yet to be implemented. And yeah, this is again a very good point. What if the display name is different? Because as you see in the demo, I'm asking for display name as well. So what if the display name is different and not enforced, so someone can just log in and take someone else's name? This one I fixed it actually. So basically the way I fixed it was I have this display name map. So I make sure that whenever you're chatting, whatever display name you set will be added to this map. And if you again try to use the same display name, it will give an error telling that display name has already been taken. So that's how I incorporated this feedback. Uh, and yeah, that's pretty much the feedback. And yeah, like this was, yeah, as they mentioned, this was like a very new project. So that's why I had not implemented like server side rate limiting, db, and many of the little things that actually matters, like managing the length of the username, password, having like a rate limiter, which is very important. Because if I don't have a rate limiter, then someone can easily flood my server. So all this feedback was good, and the reason I'm making this video is I felt that those of you watch the previous video, like it will benefit you also to know, like in a real world scenario, like what are all the important things that need to be taken into consideration when building things at scale. So yeah, thank you so much for watching my YouTube video. Stay tuned for more such content, and also please subscribe.